All right. So this is the second half of kind of our first day apart. So, yeah. I want to point something out that we're getting towards the end of the chapter. And that means they want us to begin to kind of get all of our knowledge together. And they want us to do that with one of these webs. And I have been, as I've been going, adding stuff to the web that we had in class. And this reminds me that you might not have yours. Yours might be sitting in your file folders over there, and that's okay. What I'm going to do is I'm going to leave a desk outside of my room. You come in the building when you're available, grab your folder, and then you can add to your gold sheets and even use them on assessments. I'm cool with that. So I'll be leaving that out soon, just so you know. But I've been adding stuff, like today we're going to kind of add onto this idea of the table and what the table can tell you. And I mentioned briefly that there's this connection like repeated numbers. Like what's that about? And then, you learned in the last video about the vertex form. I would put that on my note sheet, put that on the back, along with a couple other forms I'm about to talk about in a second. Today we're going to talk about a lot of these kind of connections. And again, I'm going to add to it as we go, and we'll summarize it in like the next video. But like what you're going to learn in a minute is that when you're given a table and they ask you to write an equation, that feels scary, but there's some tricks to it if we just make some simple connections. And one of the tricks is the zeros. Like if I have a 0 in the x part or a 0 in the y part, that tells me something about that equation. So I can use that, and I'll point out to you about that in a second. But what I wanted to point out to you first is that in the book, in the math notes box at the end of this section, is the thing I want you to take down in your notes. And it kind of summarizes everything that we're about to do, but here they are. Standard form, you know about that. The y-intercept, that's what's nice about this. It tells me where it crosses the y-axis. Great. What it doesn't tell me is where does it cross the x-axis. If I factor that, if it's factorable, I can get the x-intercepts, and here they are. I'm going to talk more about where they got that in a second, but that must be where if you put in a negative b into that, if you put a negative b into that, negative b plus b, that gives me 0. Remember, the x-intercepts are also called the zeros or the roots. If I put a negative c in there, negative c plus c is 0. Times anything is just 0, so that again must be the 0 of this equation. So the factored form. And then the last one, I call it the vertex form, they're calling it the graphing form, whatevs. But here it is, ax minus h squared plus k. The vertex is precisely at hk. Remember, it's the opposite of what's with the x, the number one error students make, right there. So I can get the y-intercept with that form, but not a whole lot else. I can get the x-intercepts from this form, not a whole lot else. I can get the vertex from this form, but not a whole lot else. So they all have their strengths and weaknesses, but what's nice is you can build a graph based on what's there. Okay, so they've got these cute little situations. First of all, the tables. And this is in problem 889. In 889, they give us these tables, and like I said, I wanted to talk to you about like how do you handle the tables and what can you get from them and all that kind of stuff. So here's what you can do when you're looking at a table. Like I said, look for where the zeros show up. That tells you something. Now, by the way, you can plot all these points, and I hope you do. I hope you plot these points, negative 4, 6, negative 3, 0, and so on, and so on, and so on, negative 2, 4. That should be negative 4, I think. Let me look. Yep. -2, -4, -1, -6, so on and so on, 0, 6. But I just want to point out some stuff for you if I can, and maybe you're seeing it as I'm graphing it. I hope you are. 3, 6, and then I've got 4, 14. I didn't make my graph tall enough for that, so. So I'm going to just point out some things that I noticed. First of all, as I think about this curve, I know it crosses here and here. I know what those x-intercepts are. So I know that at -3 and at +2, where this thing crosses the x-axis. Put another way, if I have x plus 3 and x minus 2, I will have the zeros of this equation. What I mean by that is, I'm good. Like, this might be my answer. If I set this equal to 0, well, -3 put in here makes this 0. Times anything is 0. -3, 0. Put a 2 in here. 2 minus 2 is 0. Oh, times anything is still 0. 2, 0. Oh. Now, if you didn't see that, you remember from what our prior videos said, you can just write these two little baby equations out, add 2, subtract 3, and I got the -3 and the +2 that I'm supposed to get. So I'm good there. This equation matches that. Just notice that the x values on the x-axis are opposites in the equation. When it's with the x, it's the opposite of what's on the graph, just like with the vertex form. So I've got the factored form of this thing. I think that might be my equation. So I'm going to sketch this graph. I don't know, like, exactly where that vertex is in terms of its height. I know it's between these two values, and here's how I know. Check out the table. Remember, looking for patterns. Math is about patterns. Oh, look at that. That's repeated. That's repeated. That's repeated. That's repeated. Now, normally what happens, and you'll see it in the next table, what happens is you get repeat, and then you work your way to the middle. Repeat, 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 and then typically, not all the time, but typically right in the middle is where the vertex is. Problem here is it must be halfway in between these two, and they don't give me that value. I know it's at -0.5, but I don't know the y value. I know it's going to be a little lower than -6, like -6.5, but I don't know. So I'm good. I've got my equation, and just for kicks and grins, I want to check if my equation is right. So I got Desmos going ahead of time, and I put in what I thought was right, x plus 3, x minus 2. And if you take a look at it, it crosses the x-axis here and here. And the y-intercept they give me is at 0, -6, and 0, -6 is in my table. And, oh, now I can just have it tell me the vertex. I knew where it was in terms of x, is at -0.5. Oh, it's at -6.25. Okay. So I've got my equation. I can use Desmos to check what I have. In fact, I had a coordinate that was 3, 6. So can I go to Desmos and go to 3, 6? Yes, 3, 6. By the way, I can move my finger, works the same way on the iPhone app, by the way. I can move my finger along the function to get coordinates. And at 3, 6, I've got one. It's kind of sweet. Anyway, let's go to this next table, 889b. Remember that as I go, if there's some... Oh. Time to go to the next class. Anyway, if you find something you don't understand in the video, please pause, go back, and rewatch. Let me try part B. This might help you. I'm going to kind of do it backwards. I'm going to look for patterns. First of all, I see that there's a 0 right here, there's a 0 here, and there's a 0 there. These are my x-intercepts and my y-intercept. So now I can graph this bad boy, negative 5, 0, la la la, 0, negative 5, la la la, and I might have it now, 1, 0, la 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 la. That's not bad. In fact, I can graph a couple more points, and in fact, the one I really want to get is this bad boy right here. And I'll come back to y in a second, but negative 2, negative 9 is right here. I believe that's my vertex. I believe it so fervently that I'm going to go ahead and sketch my graph with great, crazy, marking confidence. And there it is. That's my equation, that's my graph, that is my song. La 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 la. La la la. Here's how I know that that's the vertex. Check this out. Again, look for patterns. OMG, that's repeated. Repeated, repeated, and repeated. So you can always go and find those first pair of repeated ones, and then you work your way into the middle. Huzzah, that is the vertex. That's how I knew it so confidently. I knew it because of the patterns I know from the table. Also, I'm not done yet. They want the equation of this bad boy, so I gotta give them what they want. So it crosses the x-axis here and here. Remember, it's the opposite. So it's x minus a negative 5, which is x plus 5. X minus 1. How do I know it's x plus 5 and x minus 1? Because when I set it equal to 0, x plus 5 equals 0, and you can do this until you get confident with it. Remember, you add 1, subtract 5. You can do this until you go, oh yeah, x is 1 and x is negative 5. So to go into the equation, I gotta have the opposite of what's there. Or, you could check in Desmos. So again, I've got my Desmos all warmed up here. X plus 5, x minus 1, right here, kablamo. Sure enough, that's my graph. X-intercept at negative 5, x-intercept at 1. I got my y-intercept, for sure, 0, negative 5, and my vertex is at negative 2, negative 9. So this graph matches the graph I sketched, which matches my table. Feeling a whole lot of confidence here. So again, to recap, you can connect some things right off the table to write your equation. X-intercepts give you the factored form of the equation, if you're given those. Now we might have to do a little tweaking, and we'll talk about that in the next one. And you can go ahead and grab other things like the y-intercept or the vertex if they give it to you. Sometimes they don't. And of course you could just plot the points. This problem though wasn't satisfied with the graph. They wanted the equation. The answer to part A is this equation, and the answer to part B is this equation. We just use Desmos to make sure we have it right. Okay? I want to move on to problem 890. And in problem 890, they give us this stuff. They're giving us, and they love to do this, and I'm sure you remember how they love to come up with cute little situations. And the situation is, oh, you work at a company that gives equations of parabolas. And that's cute. And the situation says that there's this person, and they're perturbed in Pennsylvania. They wanted you to send them an equation for a parabola that goes through these 2 points. Pause. Do you notice that those are the x-intercepts? You know you have an x-intercept when the y is 0. You know you have an x-intercept when the y is 0. Okay, so given that, what I can do is I can write my equation. And I don't have to think too hard about it. They're kind of handing me what I need. if I think about what I did in that last problem, I can just write, remember, it's the opposite of what you see here. X minus 1, x minus a negative 6, x plus 6, done and done. Here, x-intercepts. This person who is agitated in Alaska, they gave the graph, and from there I can see the x-intercepts are negative 3, x minus a negative 3, x plus 3, x minus 2. Done and done. And in a moment I'll show you Desmos and how it shows that, yep, these are right. This guy. How do I get just one coordinate? I mentioned to you in a prior video how you can get 3 types of solutions with parabolas. You can get 2 solutions, that is, with quadratics, you can get 2 spots where it crosses the x-axis. You can get no spots. We had a problem where the graph went and it never crossed the x-axis. Even though it's a smiley, it's a problem. It never crosses and there's no solution. When you get to Algebra 2, you'll find out that there really are solutions. It's a kind of a next level thing. So you can have 2 solutions. You can have no solution and you can have 1 solution. How do I get this parabola to go and just get 1 solution? And it still has to be a parabola, so I have to have something squared. It's always like if I FOIL this out, if I put the little box, I'll get an x squared. Same thing here, I'll get an x squared. So what do I have to do? Turns out, friends, that you simply write that x-intercept, x minus that number, and square it. And that parabola will come down and go back up, and it'll just touch the x-axis 1 time. And that's it. And that is how you will get a single solution. It is also, by the way, if you're wondering like, well, why is that okay? Well, you can also write it as x minus 5 and then another x minus 5. If the factored form like this makes you feel better, it's totally fine. But just notice, it's written twice. Since it's written twice, I might as well put it squared. I mean, save a little time. Let's go to Desmos, find out like, how does that work? So in Desmos, I want to turn off the other 2 equations, and if you see my next 3, bang, bang, and boom, are there. X minus 1, x plus 6 is the black curve here. And I have, it crosses at negative 6 and 0 and 1 and 0. And that's what they wanted me to do. So this graph does the job. They didn't ask anything in particular about the y-intercept or the vertex, so I met the requirement. X minus 1, x plus 6 does the job. X minus 5 squared is the red one. Check it, that's where the vertex is. That is the only 0 or x-intercept of the curve, 5, 0, done. That's it, there's nothing more. So writing it as a x minus 5 quantity squared does the job. And last but not least, this x plus 3, x minus 2, I have, here is the 2, and here is the negative 3, 0. Those were the 2 coordinates. But there's something I did wrong when I wrote my equation. So this one faces up, and it's positive up front. Same with the one here, the black one, it faces up. It's what I call a happy, smiley parabola. It's like the smile on a grin, right? So it's positive out front. Positive out front, uh-oh. This one has to be negative because it's frowny. It's facing down. It's a frowny parabola. So now I gotta fix my answer. When I get back here, I gotta fix my answer. Right here. And because that thing points down, I have to add the little negative out front. I failed to notice it, but thank God for Desmos. It was there It had my back. That was awesome. Okay, so you could go from a graph to an equation. You can go from just one coordinate to an equation if you know that that's the only spot they want to cross. 2 coordinates to an equation. Now they're looking at it differently. In number 891, they want you to continue looking at these problems, but they want you to look at it a little differently. They want you to do what's called generalizing. And by that I mean, the first question they have in part A, and I'll let you pause and read the problem in the online book, but the first question they have in part A is, what's the significance of these two? Well, remember, you can set them both equal to 0 and then solve, and those become the x-intercepts. So you can say, oh, I know what I can tell you from this. The factored form, remember that box you took down in your notes? The factored form gives me the x-intercepts. And I know that they are at negative b comma 0, whatever b is, and that the other one is at negative c comma 0, whatever c is. That's what I can tell you. If A is positive, it points up. If it's negative, it points down. But I can tell you for sure where it crosses the x-axis. It crosses the x-axis at these 2 points. So what they want you to do now is they want you to go back in time. You remember the rubber balloon problems? And in one rubber balloon problem, they gave you either a graph or they gave you a couple spots where it crosses the x-axis. They gave you like the height of it, and they gave you a table, and they said, we'll try to figure out the other parts and all of that. Well, we're back to it, the same collection of problems. My x-intercepts, as I look at this, and this is good, this is fine, it's not everything. My x-intercepts are at 0, 0, and positive. Remember, it's always the opposite of what's there, 8, 0. Problem is, what I don't know is, what the heck is A? So what I did is I pulled out Yield's book here, and they gave me the graph again. And I did the squinty thing in the bifocal old man. And I looked closely and I found a coordinate. I found this coordinate right here, 114. And what that tells me is, sure, I've got x-intercepts, but in order to finish this equation, I need to plug in a number for x. Everywhere there's an x, and plug in a number for y, there's the y, and just solve for a. So y is 14, x is 1, and I'm putting that x in everywhere there's an x, and the only thing left is a. So let me just solve for this. 1 minus 0 is 1. Multiplication is happening in here, here, and here. 1 minus 0 is 1. 1 minus 8 is negative 7. So my equation is a times negative 7 is 14. And we know from the fall, from all those equation solving things, we know that all I have to do is divide, and I get that a is negative 2. So now I can write my equation. Y equals negative 2. X minus 0 is just x. It's just negative 2x. And then x minus 8. That equation will give me these x-intercepts and go through that coordinate. And if I graph it on Desmos, and I think I might in a minute, I'll see that very same graph. I can even check the coordinates on here against what's on Desmos. It's pretty sweet. So, in part C, all they wanted us to do is change this from factored form. When I've got parentheses, it's likely either factored form or vertex form. From factored form to standard form, which is a highfalutin way of saying just distribute. That's all. And all they mean is negative 2x times x is negative 2x squared. Negative 2x times negative 8 is positive 16x. That's what they want in part C. That's all they want in part C. Again, they use the big highfalutin language to freak you out. I hope it's not working. Here we have the end of this problem 891. And in problem 891 part D, They gave me the fact that this person, Al, released his ball from the 10-yard line and from the 16-yard line, and it reached a height of 27 yards. We had a nice discussion in class that day, and I said, wait a minute, doesn't the vertex have to be somewhere? I mean, if he's releasing the ball, and it comes back down, the vertex has got to be up here somewhere. And I asked you, is it okay, is it up here? Like over here? And you said, no, dummy, no. No. I said, well, how about over here? Could the vertex be over here? And the parabola goes, there's a strong wind, and the wind blows the water balloon back here. And you were like, no. So we discovered the vertex has to be precisely halfway. At 13 yards is halfway between 10 and 16, and if I go straight up, and there's 27, I can plot the path of this water balloon. Splat. And it hits the ground. That's what happened. In all of its righteous glory, that is what happened. So now in part D, they're saying, find a rule, that's their fun way of saying, write the equation, that represents this situation. Well, this, what they're asking me to do here, is exactly what we did in part B. And in part B, I plugged in 114 to get the A value, and then I got the equation that represents that situation. Okay, so same thing here. I'm going to write my situation into an equation. I don't know what A is yet, but I do know x minus 10, remember, minus what's there, it's the opposite of that number. And then x minus 16, opposite of that number. Now the game is, I got to plug in a coordinate to figure out what A is. Well, my coordinate is the vertex. It's the only other coordinate I know. That coordinate is 13, 27. That's where the vertex is. So now that I know where the vertex is, I can plug in 13 here. Again, wherever x is, I plug in the x part, and then 27 for y. And then I just take my time. 13 minus 10 is 3. 13 minus 16 is negative 3. 27 equals a times negative 9. Oh yeah, I remember from this problem, I got to divide. And I do that, a is negative 3. Yippee skippy. Now I know my equation. Y equals negative 3, x minus 10, x minus 16. Done and done. We can take very little information, stuff given to us in words, and we can graph, we can write the equation, we can create a table just from the stuff that they give us in words. It can be done. You may want to rewind this whole problem and walk through this again, because I know I'm going through it quickly, but there's a lot to be picked up just by putting down what it is that's the important parts and translating it to the language of math, to the language of graphing and equations. Part E, last one. Then there's this guy, Imp, and his water balloon toss, and they gave us this. And here I go. I'm doing what I did before. I see a 0 right here. I don't see any other zeros, but now I'm going to look for that other pattern I brought up last time. Like 24 gets repeated, 21 gets repeated. So this bad boy, that must be the vertex. That's my vertex. I don't have the other x-intercept. So I'm kind of in this place where I'm like, I'm not sure what to do. I definitely know my vertex. I know one of my x-intercepts, but I don't know what the other one is. Now, here's what I could do. I could break down the wall, I could get another dry erase board and screw that into the wall, and I could extend my board, because that's a reasonable thing to do. And I could do that, and I could extend my board, and I could have 10 and 16, and then I could have 11, 9, and then I could have 12, 0. So I know I have another x-intercept at 12, 0. So we have two choices. We could say, you know what? You know what, buddy? I'm going to write this in vertex form. X minus 7, remember it's minus the x part plus the y part. And then I could plug in any of these coordinates and figure out what A is. I could definitely do that. Or I'm going to do what I've done before. It doesn't matter which way you go about this, but just for the sake of, you know, sticking with a common plan, A, x minus 12, and x minus 2. And I have a coordinate. I could pick any old coordinate I want, just for kicks and grins, just for squirts and chuckles. Squirts and chuckles is the school-appropriate way of saying the other thing that your dad says. So for squirts and chuckles, I'm just going to pick the coordinate 3, 9. 9 is the y part, 3 is the x part. And just like before, like I did in the prior two problems, I'm just going to grind this out. 3 minus 12 is negative 9. 3 minus 2 is 1. Hey-oh, negative 9 times 1 is negative 9. And if I divide positive 9 by negative 9, I get that A is 1. Whoosh. So since I have that A value, now I've got my equation. It is just y equals negative 1, x minus 12, x minus 2. Sorry that it's crammed in there like that. But again, if you take a second and analyze what we've done so far, analyze a table, graph, situation, you can write the equation. It's not too bad. Now what I want you to do is go ahead and attack the homework that is in our homework document. Take care.